Antarctica. Pristine. Endless. Then red. A bleeding glacier? Baffling scientists for a century. Meet blood falls. Not blood. Iron-rich brine oxidizes on contact. Trapped beneath Taylor Glacier. Science, not horror.
If your glacier looks like a strawberry smoothie, you're not looking at algae. Early explorers made the same mistake. For centuries, travelers called it blood snow. They blamed algae. That fit a simple story. Red on top, life at the surface. But modern science flipped the script. The red, along with pockets of liquid, it doesn't come from atmospheric melt or from surface microbes. It comes from deep inside the glacier. Pressure, geothermal heat, trapped salts. These create tiny saline layers that melt. Those sub-ice liquids rise and stain upper ice as they migrate, carrying minerals. Microscopic pigments. They look like algae but aren't growing there. So the myth, surface algae causing the color, is busted. The fact, hidden internal melting and chemistry paint the ice from the inside out. Nature, dramatic, mysterious, trickier than first impressions.
That red wash, it's not blood, it's not pollution, it's metal catching air. Here's the quick science we're looking at: iron-rich salt water. When dissolved iron meets oxygen from the air, a chemical reaction kicks off. Iron oxidizes. That's rust. But in the sea, it happens fast, and on a big scale. Salt water amps the process up. Salt conducts electricity and helps electrons move, so iron gives up electrons to oxygen faster than it would in fresh water. Tiny particles of iron transform into iron oxides, hydroxides, solid rust suspending in the water, turning it a vivid red. It's not paint, it's not dye, just chemistry that's loud and visible. Sometimes the source is natural, like underwater vents, mineral-rich sediments getting stirred up. Other times it's human activity exposing iron that oxidizes quickly. So next time you see that red tide-looking patch, remember, oxygen met iron and rust won the day. Science, simple and dramatic. Want to see it up close? Stick around for the slow-motion reveal.
If you don't like cold but still love surprises, then listen up. Imagine a hidden ocean under a glacier. Now imagine it's been sealed off for millennia and teeming with brand new life. Beneath a kilometer of Antarctic ice lies Lake Mercer, a dark, salty world cut off for millions of years. Scientists sequenced over 1,000 single cells and found mostly brand new microbes, genetically isolated from the surface. They don't rely on sunlight. They chew ancient carbon. They burn inorganic chemicals, switching metabolisms depending on oxygen. These chemosynthetic strategies, and heterotrophic strategies, let life persist in total darkness. Over 400 similar subglacial lakes could be hiding microbes. They're models for life on icy moons. The big takeaway: life adapts, even in the loneliest, strangest places.
Dark, salty pools under ice might sound like horror movie sets, but they could be life's hiding spots. We just wrapped up the idea life surviving in isolated, dark, salty water changes the game. On Earth, microbes thrive where sunlight never reaches. They eat chemicals, not light. Salt and cold don't kill them. They use salts to stay liquid and stay alive. Now translate that to Mars. Subsurface brines, frozen crust pockets of trapped water conditions that used to look impossible for life, suddenly look plausible. That doesn't mean Martians are waiting for us, but it opens real, testable possibilities: microbes tucked under ice inside salty soils. So future missions should probe below the surface. Target salty spots. Look for chemical fingerprints of life rather than green things. Bottom line, if life can survive in those extreme hidden waters here, then the mantra applies. If here, then anywhere. The universe just got a lot less empty. Subscribe for more brain-bending science in under a minute.